We move now to the part of the kernel that is the input-output subsystem. We are going to look at some specific aspects and things that are done at this level in the kernel. So the services we are going to look, or the things we're going to discuss here, it's the scheduling of input and output. We will see at the buffering, caching, and spooling mechanism. We will discuss also a bit of how type of errors we can handle and different ways to handle them, and also some we discussed rapidly why there are also needs for protecting specific parts of the memory, and that is also part of what the I/O subsystem does. So scheduling. We discussed many times, I made many examples of processes that need to write something on disk and then they go into the waiting state and so on. So it turns out that the requests that are made by many processes are not necessarily executed in the same order they are made, okay? The operating system, the kernel, the I/O part of the kernel subsystem can optimize and change the order in which it serves the different requests depending on the hardware is interacting with. The example here would be for a rotating disk. So if, let's say you have three applications, 1, 2, and 3. One wants to read or write something at the end of the disk. The second one wants something at the beginning of the disk. And the third one needs a block near the middle of the disk. Then you see that if you just go in this order, then you have to go to the end of the disk, then back to the beginning of the disk, and then go to the middle of the disk. If you have the ability of shuffle the order and go in a different order, it might be that it's actually better to execute this request in the order 2, 3, and 1. You can start from the beginning of the disk, especially if you're already there, read what you need to read, then go to the middle, and then go to the end. Of course, it is specific to the hardware. This is a rotating disk. An SSD disk doesn't really incur different times depending on how far you need to go in the disk. So this kind of optimization wouldn't really make sense. Now, as always, trade-offs. This is an optimization that can increase performance. So the scheduling requests in specific orders depending on the hardware. But then you will need to keep extra information. So basically, it is no longer true that as soon as you get something, let's say from the disk, that is information that is for the first process or for the process control block that is first in the queue of processes waiting for the disk, because you are no longer serving requests in order. So now you need to add extra information in each process control block, or to keep track of what is that they are waiting for. And when you get something from the disk, then you can find out which one is the process control block that you can move back to the ready queue. The operating system, the kernel, will also use buffers. Okay, so when you are accumulating data that will later be sent to the disk or to the network, you actually keep that in memory. You keep accumulating that in memory. That's a buffer. And once the buffer is full, then you transfer the data to the device. Now, you actually need two buffers. It's the double buffer mechanism, because once one buffer is full and you start transferring the content of the buffer to disk, for example, that will take a certain amount of time, and you cannot keep adding stuff to the buffer in that amount of time. So what you do is that you write that buffer and you start using a second buffer to fill stuff, and then you keep switching between the two. Every time one is full, you start using the other, and you write the first to disk or to whatever device you're interacting with. This is also done because of the different speeds with which the devices can read and write data. Here you have just some example number. This is an old slide, but it still shows what I'm trying to say here. And there is a second mechanism that is used by the kernel, which is caching, and that is similar to what we discussed already when we were discussing caches at the hardware level for the memories. So there are copies that are kept at the operating system in memory, at the memory by the operating system, so that if you try to access that thing again in the immediate future, you already have that in memory. You don't need to interact again with the device, and also the kernel will take care of creating a queue and keep and holding up the output for specific devices if these devices can only serve one request at a time. Okay, so this is handled automatically by the operating system, and this is the spooling mechanism. When it comes to errors, as you can imagine, the kernel will have several routines, several parts that are dedicated to handle errors, and here you can distinguish between permanent and transient errors. Maybe you have experienced this yourself if you use a rotating disk. Rotating disks, but also SSDs, but rotating disks, they tend to fail after a while, and some sectors, some parts of it become, they stop working. So you can still use the disk, but some portions of it will become unusable. So when that starts happening in your machine, eventually the entire disk will just be corrupted. So it's a sign that it's time to change the disk. Still, the operating system has routine to find out that some sectors might be damaged, and it will still try to operate with the remaining ones. So all these things are part of the handling of or they are supported by the fact that there are components in the kernel that are about handling errors for input or output operations. And then, of course, there is the part about protection. This we discussed basically since the beginning of the course. I think I'm not saying anything new at this point. The very first thing we discussed was system calls, and now at this point you can probably understand how a system call is a complicated thing that requires interaction with many parts of the operating system, and everything is done in the spirit of protection, so that you basically protect the users from the hardware, but most likely hardware from the user and from the different processes. Here is an example of protection mechanisms.